Hello, everyone, and thank you for joining us today as part of the Omni-Air Global Plug Fest. Today's panel is C-V2X and the global race to 5G. My name is JonMichael, Assistant Director of Transportation at the City of Austin. And under my portfolio, the Smart Mobility Office is assisting Omni-Air with part of the Global Plug Fest. I'm very, very excited and proud to have with me today three of our colleagues that are working on global standardization and harmonization of C-V2X. And I'm going to get to those folks in just a second as far as an introduction. Before I do that, I kind of want to take a moment and set the tone for what we're going to be talking about today. As everyone's aware, the media has presented a global war, if you will, related to DSRC and 5G and C-V2X. And a lot of us who spend most of our careers working in the RF environment realize that that's just not the case. And some of the things that we'll be discussing today will be reducing some of those anecdotal frameworks that the media loves to put out there related to the difference between these technologies. And moreover, we're going to better understand how both technologies help enable the future and what the natural progression of some of these technologies may be. And with that, I'm going to ask that each of the panelists please introduce themselves, their company, and a little bit, one small item about themselves. And I'll start with Jim Lansford from Qualcomm.
All right, thank you, Jason. Good morning, good afternoon, good evening, everyone. Happy to be with you today, and looking forward to an exciting week in the with the Omni-Air Plug Fest and technology workshops that we're doing. My name is Jim Lansford. I'm in with Qualcomm's Industry Standards Organization, and we are, of course, been heavily involved in developing the standards around C-V2X. As a company, Qualcomm was one of the early developers of chips that could be used for DSRC. We've been heavily involved in the software stacks, helping our partners enable the software stacks that go above the radio. And then in the last few years, we've shifted our focus to C-V2X. We have a number of standards efforts that are involved in promoting C-V2X within the European framework as well as in the US. I actually am the editor of the SAE standard J3161/1 that it will be the foundation for the C-V2X deployment in the US that you heard about earlier in the Ford keynote. So we're very excited about the technology. We think it's going to be a great benefit to society, and looking forward to the panel today. And hopefully you'll find something of value in some of the topics that we bring up and the discussion we bring to the community.
Hello, everybody. Can you guys hear me?
Laszlo, will you go next, please?
Thank you, Jason. Hello, everyone, and good morning, good afternoon, good evening. My name is Laszlo Virag. I'm CTO of Commsignia. Most of you already know a little things about Commsignia, but just to refresh those memories, basically, we are fully focusing on V2X, vehicle to everything communications, since day one. And actually, we provide solutions for automotive, smart cities, smart infrastructure, smart highways. And at the same time, we are also contributing to the standardization, also to the certification from a vendor perspective. So in this panel today, I would like to represent that kind of perspective and share our ideas and our vision, basically, on different questions related to C-V2X and 5G, alongside with Omni-Air and the Omni-Air certification. Another thing that, as you may already know, we were the first who certified a DSRC unit back at the day with Omni-Air, and we are really looking forward to achieving other certifications as well for the upcoming evolutions of our product line. Thank you so much, Jason.
Thank you, Laszlo. Thomas?
Yeah, hello everyone. So warm welcome from my side. My name is Thomas Jaeger. I'm the head of the technical service management responsible for automotive and connectivity product testing services at DEKRA on a global basis. Actually, I'm situated here in the center of Europe in Germany. And as you know, we are represented all over the world. And as you also may know and maybe remember, we have hosted one of the very fantastic Omni-Air Plug Fest last year, actually at the same time in our nice premises in Malaga, Spain. I think that was a fantastic event. I see Jason still smiling. We are all it's very sad that we have this situation this year, but however, I think we all make the best out of it. And to say we are also really proud to be part of this festival this year once again, while also using our facilities in Malaga, this time virtually, where this week actually the first testing sessions are going to be started. And I think it's quite exciting for all of us to see how that's going to happen. And I think we will have certainly some kind of hybrid approaches in the future. So I think for all of us, it's good to make some experience in this direction as well. So I would like to thank everyone here for being a part of this. And I think we are all excited to see what's coming up during this week. And I would like to wish all of us a very successful week. Thank you.
Thank you, Tomas. And lastly, Alain, could you please introduce yourself? Sorry, Alain, you think you joined right at the end there. We're just going through introductions really quick before we get started with the panel. I can't hear you yet, Alain. It looks like Alain may be having some issues with his audio. Bonnie, I think you're listening in. If you could assist Alain off channel, we'll continue to move forward with the panel and ask Alain to join back when that time's when we've got that fixed. So in the meantime, Alain, I'm going to mute you from my side, if that's okay, and we'll get started here in just a second. All right. So as Alain works that out, we'll go ahead and kind of set the tone and get some questions and answers going here. So let's talk a little bit about DSRC or ITS 5G in Europe and C-V2X. The name of this panel is the global race, which I think is a unique term, considering that we're all trying to understand how to correlate the differences across the world with what's happening in connected vehicle technologies, especially from the perspective of the OSI stack. I think that each of us will have a unique perception related to the physical layers of that stack versus the upper layers of that stack and what's happening here. And so we're going to use that as kind of our guide tool or our compass by which we communicate today. So both DSRC and ITS 5G have been around for a while. My first question, I'm going to start with Jim and then transfer this to the others, but we'll start with Jim on this one. What are some of the advantages that come with C-V2X that you see?
So one of the as many of you know, we've been working on the stacks for intelligent transportation for a long time. In fact, 802.11p, which is the foundation of DSRC, was started 15 years ago and is based on 802.11a, which was adopted in 1999. So there was a lot of work that went on. And if you look at the overall OSI stack, as you mentioned, we have at the lower layers the radio itself. And then above those radio layers, we have a great deal of work that's gone on both in ETSI in Europe as well as SAE and IEEE 1609 in the US to develop all these the software layers that allow vehicles to communicate with each other. What we've done in the last few years is we've replaced that 11P technology, the older based on 8211A 20-year-old technology, with a modern LTE-based radio. It's derived from 3GPP specifications that are that's the organization that develops all the cellular standards. It's a more modern radio. It has higher performance. It performs better in non-line of sight. So it performs better through trees and around buildings than DSRC does. But we still leverage all of the same rest of the stack that was developed for DSRC. So all the upper layers above the radio, all the message types, all of the protocols, those are all still the same above the radio. What we've basically done is replaced the lower layer, the old the piston engine, if you will, with a more modern high performance electric vehicle kind of if I can use that analogy. So it's a higher performance radio, but we still leverage all the rest of the stacks that have been developed over the last 15 years.
Thank you, appreciate that, Jim. And so from, if we look at this from the perspective of a manufacturer that manufactures some of this equipment, Laszlo, what are some of the advantages that you're seeing in C-V2X as it's compared to DSRC with, not only how your product line and roadmaps are developing, but also what your clients are asking and looking for as well?
Mm-hmm. Yeah, that's a great question. And just to give you the context, we do develop basically roadside units and also onboard units for smart infrastructure. And as part of that, we also implement C-V2X functionalities for the last, I don't know how many years. And we think that's a great evolution step on the V2X roadmap. From a vendor perspective, it's hard to say, what is better and then what is, worse in case of a product or a technology. But our mission here is basically to fill the gaps. And if that's a new radio technology, we will certainly do that. So that's our plan, and that has been our plan since day one. And just to give you an example, we also facilitated and implemented Wi-Fi 3G, 4G connectivity next to the direct point-to-point V2X kind of communication in our solutions. And that is also applies for our software solutions, which goes into automotive products where we are not the manufacturer of that equipment, whether that's a simple ADAS box or a complex autonomous vehicle computer or controlling unit in the car. What is important for us, and of course for the customers, the end customers, that the software solution and the whole solution should support basically all the available radio access technologies, and of course all the middleware components which are coming from these vendors. We see a high demand, especially for the last 1.5 years for C-V2X, and also for dual mode units, especially on the infrastructure side. But maybe there's another motivation for that. So I hope I answered your question with that. Great.
Thank you, Laszlo. Yes, you did. In fact, it kind of leads into my next question. So I'm going to hold with you for just a second before pivoting to Thomas and Alain. But there seems to be this convergence happening along a lot of different lines. To your point, both current 4G LTE, C-V2X, Wi-Fi, and other radio mechanisms in order to gain more connectivity to the vehicle. And it seems like there is a convergence that's happening in the automotive space. Before I jump into how that's affecting test houses and test equipment providers, just one last time or one last mention from you. What are you seeing from an auto manufacturer's perspective globally? Laszlo.
Yeah, okay, yeah, I didn't realize, sorry. From an auto manufacturer, basically, their view is that they won't spend, a single penny for an additional radio, that's for sure. So for them, what is important that there's supposed to be one radio for one feature or one purpose. But sometimes they prepare basically for both or every single possible outcomes. And they really rely on the suppliers and vendors to support every single outcomes, whether it's the best case or the worst case scenario. So that really depends on the OEM. And OEM, I mean the car maker in this space. What's supposed to be the actual technology, whether it's technology A or B or C. But typically, we have to be really prepared with our V2X software and the software stack to support technology A, B, and C. And sometimes we have to do some kind of comparison as well, or help they work. But you know, the trend is more and more OEMs are interested in cellular V2X, and especially fused with 5G capabilities.
Thank you. And as you know, an infrastructure owner and operator in this space, I can tell you that, you know, here in the city of Austin, we're paying attention to that because we have very limited resources. And so it makes sense for us to make sure that we're watching the market sector, we're watching what's happening, and we're finding ways to enable that either through our built environment or through the policies around purchasing that we have. And so I'm going to pivot to Tomas and Alain here. You know, from what Laszlo laid out, I know it makes it hard on me to try to understand, you know, how much do I invest in DSRC today versus waiting for C-V2X tomorrow. We have a very limited amount of funds and resources to be able to invest once, and so I want to make sure that I'm doing something that's in the best stewardship of Austin taxpayers' dollars, and making sure that we're developing a built environment that has the ability to bring around this life-saving technology in a way that is sustainable throughout the different market pivots that will likely happen. And so, starting with you, Tomas, from a tester's perspective, from a test house perspective, how are you guys making sure that you're able to bridge the gap between the needs of Laszlo, for instance, and what you're seeing from some of the test equipment manufacturers as well?
Yeah, thanks for this very good question. I think it's very challenging nowadays, especially starting actually in the history from DSRC, where we started, of course, quite early to develop all the different means, what is really necessary for this kind of technologies. And I think we had these different flavors in North America as well as in Europe. And I have to say, maybe also go a bit back into the history. You know, that development was quite important, really, because we learned a lot. You know, that helped us then later on also when it came to cellular, because a lot of lessons that we have learned also with DSRC were quite important and later on what we were doing in cellular. And I think that is also very much related also to testing, where, you know, the methods we are using, we have developed in the area of DSRC are very similar to what actually also is actually needed in cellular V2X, and where we can, you know, make use of all of this knowledge, what we have done so far, and just convert it now to additional BERA technology that is now being used. Because as we all know, there are a lot of commonalities, and especially the higher layers, you know, can be used as they are, and the standardization has adopted now quite quickly, quite fast. So I think, you know, the cellular camp can be quite happy that all that work has been done before already, and the wheels, or a lot of wheels, there is no need to invent them again. So I think in order to secure a lot of things, especially, you know, for the different applications, I think it is quite important to have many different facets of testing and verification. And of course, it ranges from the laboratory environments and setups all the way actually to really physically test things on the road. We have experiences, as I said before, last year. Now our nice facilities in Malaga, where we have done a lot of things on the road to test really physically the use cases. And I think we have seen how important it is and how many challenges we still have here. And at the end of the day, I think we might get back to this later on a bit more. But what makes sense or not make sense in terms of environments, depends at the end of the day, of course, on the use cases that you would like to implement. And there's a range from, any kind of traffic information all the way to really mission critical safety applications. And I think that determines then later on how you set up, how your infrastructure, how the whole constellation should look like, and how it need to be tested in more detail. So I think it's not possible to give here a kind of lump sum statement, because it really depends. But at least I can say from our point, I mean, we have been prepared to cover all the different facets, because we have seen in the area of providers, in the area of OEMs, and also technology developers, that of course finally all kind of circumstances need to be made available. So I hope I could touch your point a bit, but we can come back to some of the aspects maybe a little bit more in detail later.
And I think we might, Tomas. And I think Alain's got his audio working. So I'm going to take a moment, pause here. Alain, if you could please introduce yourself and your company and what you do in this space.
Thank you very much, Jason. I hope you guys can hear me this time around. Excellent. Wow. I'm glad to be here. Thank you for giving me and Spirent this opportunity. We at Spirent are one of the leading test tool providers in V2X. We started working on DSRC way back when the certification program was initiated. And we were working with 7 layers, which is well-established test lab. And we helped them starting that program, and then later on it was it migrated to Omnia. And recently we started now also supporting the CV2X effort. And Spirent, our solution are mainly focusing on the signaling protocols, and for that we are qualified as to provider for Omnia, and our solutions cover all regions, so the different protocol stacks that are available for both CV2X and DSRC. So that is the US Wave protocol stack, the EU ITS, as well as the China recently introduced protocol stack. Yeah, so it's a great honor to be here, and also to give a bit of a perspective of how we think testing will play a key role in driving these technologies and pretty much fueling this race to 5G. Great to be here. Thank you, Alain.
And to that end, I'd like to ask you one question before I pivot off of you, and that would be, you find yourself as a test tool provider, kind of the monkey in the middle between all of what's going on. You're always the guy trying to catch, just better understand, what maybe I need from a built environment perspective, what Laszlo is interested in from his ability to test and certify his devices. You got to make sure that you're working with Tomas to make sure that Spirent's test tools are available in a worldwide network of labs, and then ultimately, Jim and Qualcomm are helping march towards the future of CV2X, and being able to tie all this together between policy and standards development that's happening with regard to everyone in this call. How do you manage that? How do you manage this level of change that's happening right before our eyes right now?
That's an excellent question, Jason. In fact, and we're experiencing a lot of that with the testing starting today. So luckily, the experience we could gather with the DSRC is helping us a lot. There are two aspects that are quite helpful in that context. First, our experience, as I said, but also the fact that the CV2X technology followed this brilliant idea to keep the upper layers as defined already for DSRC. So the changes are not so significant for us. Nevertheless, of course, it's a challenge. It's a new radio. There are new requirements that you're looking at in terms of testing. And also, depending on the regions, sometimes with the specifications evolving pretty quickly, it can be one can have a tough time keeping that pace, and even in some cases, getting access to the specs themselves and being able to ramp up the test scripts in time to support all these different stakeholders is quite a challenge. But I think it's what makes also our task as test tool provider very interesting, and we're very glad when we can help there and support our customers and helping driving this technology.
Excellent, thank you, Alain. And to your point, yeah, it's tough to be always needed by everyone. You know, you mentioned the regions, and yeah. I know that for all of our U.S. participants, we may be thinking, you know, just in the United States, but that's really the world's regions. And you know, in the automotive market, especially as it relates to electronics, you know, that is really a global marketplace, and we are seeing other regions move very confidently forward in some areas, specifically in CV2X. We're seeing a significant amount of activity and adoption in China. And so real quick, before I pivot over to Jim, I'd like your insights of what you're seeing in the Asian marketplace, and what's part of Spirent's overall strategy related to how to support that level of activity happening in CV2X while also continuing to support DSRC technologies from some of your other clients.
Yeah. Yes, thank you very much for that very good question. Yeah. Luckily, given that our solutions are focusing on what is labeled as the application message layer, as well as on the network layer, and less on the file layer part of the protocol stack, right? It gives us a bit of flexibility in terms of adapting the solutions that we have to the different file layers that are in place. I think if we were to support full stacks, including the physical layers, for all the solutions that we provide, we would have had a harder time, I think, supporting our customers in all the different global regions. Yeah, I think that's one thing that's helping. And also, we're working quite closely with device vendors, with file layer chipset manufacturers like Qualcomm and others, basically to leverage on what they have on their products, on their solutions, to provide the testing that our customers are expecting.
Thank you. Jim, Qualcomm's chipsets are sold across the world, and therefore Qualcomm has a very unique focus on carrying this conversation forward. And really quick, you know, as it relates to China, and what we've seen is them taking a lead lately in the CV2X space. How has that happened from your perspective at Qualcomm, and what's really next for those markets that have already taken on that level of standardization or mandatory implementation?
So yeah, that's a good question. We certainly, and in the semiconductor market, it's a global market. For us, economies of scale in this chip business are very important. As in most of you, I think you'd rather have one product globally. And what we've seen is that China has moved aggressively to essentially mandate C-V2X going forward. Their view is that C-V2X gives them a natural pathway to 5G. And we'll see vehicles, we're already seeing vehicles on the road in China with CV2X in them. And we expect that trend to accelerate. And that's one of the things listening to Laszlo and Thomas and Alain speak, there's been a lot of work that's happened over the years, but as connected and automated vehicles, really there's an acceleration, probably a bad pun, of the technology as we've seen more and more emphasis on connected and automated vehicles. And in the opening keynote, I was glad to see Katie really highlight that. And so China, for better or worse, China is leading the charge, and they will be the spearhead for deploying this on a mass scale. Now, to give Ford credit, Ford has announced within the next couple of years that they expect to start deploying CV2X across their entire vehicle line, and so it's almost 2 million vehicles a year, about 1.8 million vehicles a year, I think, in current market terms. So the U.S. is certainly we don't have a mandate in the U.S., but we certainly see that companies like Ford are willing to step up and on their own deploy the technology. And it really is an important part of the overall connected and automated vehicle space. And so as vehicles become increasingly automated, it's that emphasis on connectivity is going to become even more important. But in China, we have essentially a mandate, which obviously creates a market. In the US and Europe, we are less likely to have a mandate. It could still happen at some point. But I think people, the market will develop based on companies trying to innovate and take technology leadership in this space. But it's, as Alain said, things are moving fast now. We kind of went at a leisurely pace for a number of years in DSRC, and the FCC said, you guys can use the spectrum or not. And I think we're seeing increasing emphasis on trying to not only use the spectrum, but to use it in ways that benefit society.
Thank you, Jim. Yeah, this level of acceleration while converging lots of different market sectors seems to be a trend that we're going to be on for quite some time.
And we've tried to ease the pain. We've tried to ease the pain for developers by preserving the upper parts of the stack. So yeah, we've got a different radio, but we're at least trying to leverage all the 15 years of work on the software stack above the radio.
And that's a very good point. That for some of us technologists or systems integrators, the OSI stack is like our warm fuzzy blanket that reminds us that with all this change and all these different things happening, geopolitically around the world as it relates to this technology, if we can entrust that OSI stack blanket to come and give us that understanding and a little bit of understanding of where we're headed, it gives us a level of comfort. And that's some of the comfort that I think a lot of infrastructure owner operators are looking for, like myself, while we look at our built environment, for instance. And speaking of China, one can't help but watch the news and see evidence of this race happening, whether it be the rollout of 5G or the rollout of other technologies that either utilize it or support it, be it Internet of Things. Just the Internet of Things in the mobility space, you can spend a lifetime trying to understand all of the different applications and technologies that also go along with a CV2X roadside unit in the future. That's really bringing forward a lot of edge compute technologies and other supporting technologies and applications around pedestrian analytics, around other near miss technologies for other kinds of safety operations. And while we're speaking directly about vehicle communications today. I think we all understand that the thing that's grander than us all is the amount of fatalities that are still happening on roads around the world. And this type of technology is the type of technology that can help mitigate or completely remove that in the future when it's combined with automation as well. And so Laszlo, from a vendor standpoint, with these 5G technologies, when we started this panel, you introduced the concept of convergence and how your clients, especially from an OBU perspective, are in definite need of wanting just to buy one radio as they look at the economies of scale of their vehicles and how employing and implementing some of these technologies, it's not just the cost of the technology, but the cost of the care and feeding of that technology over time for that vehicle line. What are you seeing in that space of convergence between Wi-Fi, other Internet of Things in the mobility space, and how C-V2X helps enable that?
Mm-hmm. Yeah, that's a great topic actually, and we could talk about it like hours or even days. But to oversimplify it a bit, from our perspective, what we can do is basically relay our customers' perspectives, because we have to solve today's issues and of course the problems of future smart mobility. But eventually, the customers, they would like to solve some real life problems, whether you are trying to save lives, avoid accidents between cars, or typical use case for vulnerable road users. They typically don't care what is the underlying technology. Of course, that's a crucial part, but in their world, it's just basically some enabling technology or a vehicle with which they can achieve their goals. Sometimes they do not care about the OSI layers or that model, which is not a problem. Typically, of course, for technologies that can be a problem, but that relates something which we usually call a language barrier between the different stakeholders, whether it's an automotive company versus a telecommunication company, or even towards cities and highway operators, where traffic engineers are sitting, and maybe we are talking about the same problems but still speaking a slightly different language, and maybe we don't get the real points there. But getting back to this, what is really important today to have the necessary communication interfaces and solutions right now, and be able to use them today and not like 5 or 10 years from now. So that's typically crucial for the customers. The right constellation of these communication interfaces, that's basically a good question, and typically it's a case-by-case scenario. So we have seen a lot of interest, for example, in conventional technologies or old technologies like Wi-Fi or 3G, just to give the backend system as a backup backend to roadside infrastructure. 99% of the time they are not using that, but there can be special cases where they would like to rely on that. Other technologies and Bluetooth or other kind of radios can be used for auxiliary solutions, improving, for example, the quality and reliability of V2X communication, for example. So in that sense, it's great to have reliable V2V and V2I communications, with low latency and high bandwidth, for example. But for many of the use cases, we don't have enough node, because the cars are missing today from the picture. So what Jim mentioned, that's great. I mean, what Ford's been doing, that's a great initiative, and what's happening in China, that's also great. But we still miss the mass number of vehicles, unfortunately, from our cities and from the roads. So with that, of course, we can leverage it, but until that time, we have to rely on other technologies as well, such as cellular type of 4G, 5G, together basically typical efficiency related informations, and to realize applications based on that information.
Thank you, Laszlo. And pivoting to Alain, you know, as it relates to how Spirent's test tools and test method development happens across the world related to other stovepipes outside of directly CV2X, these economies of scale that we talk about, how does Spirent look at bringing around those economies of scale for its customers? You know, I'm noticing that there's so many different wireless technologies that are embedded into a vehicle today. How does that overall begin to leverage any type of, how do we keep that momentum going, in other words, with the huge pervasiveness and wide range of wireless technologies that are available to OEMs today?
Yeah. Thank you very much, Jason. That's an excellent question, and that's very much in line with the Spirent strategy with regard to testing automotive, right? Because this technology is, let's say, one enabler towards the connected autonomous vehicle, and that functionality, or let's say, it's actually that system, right? It's a combination of different such technologies that need to all play together to provide the end customer, the automotive end customer, the functionality that they're actually looking for. And as you can imagine, it requires quite significant effort in terms of integration. How do you ensure that when you put all those pieces together, that things actually work as they're supposed to, right? You have physically moving elements, you have wireless communication, you have communication inside the vehicle as a network, right? So from all the sensors inside the vehicle into the IT system which the vehicles now builds as such. So how do you ensure latencies and so on? So that drives Spirent's strategy with regard to testing, and all these pieces that we are supporting are helping us to provide a system whereby we will be able to simulate different functionalities and combine that with real device on the test to evaluate how those devices on the test perform, whether they meet the requirements that the customers are actually looking for. The idea would be to have something like a car in a box, right? So where you will simulate the different components and then put your own part inside, and then do your measurements, do your testing, testing the functionality, the performance, and so on. Yeah, so that's the overall vision from a Spirent point of view there.
Thank you, and that's actually, it's part of my point of view as well as an infrastructure owner operator. I'm looking for turnkey testing solutions that test a multitude of things, none the least of which would be, you know, those vehicles and how they communicate with my roadside. You know, a lot of that right now is done in facilities like Tomas's facilities around the world.
And that's an interesting aspect. Yeah, sorry to interrupt. That's a very interesting aspect you're raising there, because the interplay of, let's say, the vehicle, right, with the infrastructure and with the network as a whole. For example, in the case of CV2X, there will be a backbone network that comes in play, application service providers also there. So how do you test that type of infrastructure, right? One can imagine that the effort for testing, if you have to do that with live testing, can be quite significant. So you would like as much as possible to keep your cost under control and do field testing where it's really needed, and in a very also let's say dedicated way. So you will be looking at something specific rather than just driving around and collecting data, which at the end are also quite difficult to analyze, right? So, yeah.
Absolutely, and a great pivot to my question to Tomas at DEKRA. You know, as one of the world's largest test houses for this, where there's your test facilities around the world are able to help bring this level of base testing up. You know, how to Laszlo's answer and Alain's answer related to, you know, how both the equipment providers as well as the test tools are utilized in your facilities. And then on top of that, you have my needs as well from an RESU perspective. How does this convergence happen? How does this convergence help or hurt those efficiencies and economies of scale as you're looking at this overall evolution and this journey as it relates to vehicle connectivity as a whole?
Yeah, I think it's, as I said earlier, it's quite a challenge to cover all these different aspects that are needed at the end of the day. And what I think Alain said, I think at the end of the day, there are so many things coming together. And in the automotive space, I mean, it's a vertical. And at the end of the day, what is relevant here are the use cases. I mean, the technology is a mean that you may use, yeah, and you may have different options at the end of the day. And at the end of the day, you would like to address, you know, your use cases in the most best economic and efficient way. That is what is of interest of road operators, of service providers. And I think that is something you need to verify finally. Yeah? And I think for us, it's quite challenging, not just to stay in the laboratory. And what Alain just said is quite true. I mean, you need certain things where you can do it without going on the road, and where you can test certain things in a most efficient economic way, and multiple things maybe also efficiently. But then finally, you still have the need to do maybe certain things also live and really in real time environments, where you may need also networks, where you need the infrastructure, where you need the real setup. That will even also later on convert into, for example, homologation. So, you know, when you have cars being homologated in the future, vehicles as such, and you have more and new functionalities in terms of connected and automated driving, this is more and more a subject that also moves into the homologation process, where you also need to demonstrate something finally. What we have done in order to address this, actually, we have integrated now into our test concept real-life infrastructure. For example, we are hosting now a real-life network in our test facilities, where we can, you know, deploy via own infrastructure that is attached to a real cellular network. In Spain, for example, we are working together with Telefonica, and we can make use of real LTE and real 5G signals, and we can even, you know, use them, configure them, and we have a real access through the network to own application services, because at the end of the day, that is what is really needed, what is necessary, and what is of interest of the various customers. So I think you can style a lot, you can make a lot of things as economic as possible, especially when it comes to the massive number of use cases. But still, finally, you have to do things also somewhere in a real environment. And I think that is not just important maybe for regulatory purposes, but at the end of the day, I would say also we all as consumers would like also to see finally that certain things are really working in real environments, because more and more is being addressed to safety applications, safety services. And I think this is very crucial. And I think, for example, when it comes to latency issues, where it's not just needed to have the pure cellular link, you need to use RSU somewhere nearby, things like that. It's too critical, too crucial, and I think you need to secure this in a way that you know, there is not any risk anymore. So I think the complementary testing needs will be still given, and I think that's an important topic, I would say.
Yes, in fact, you know, I definitely see that roadmap, hopefully ending on my streets with a level of scenario field testing that's specific to safety scenarios that we have here in Austin. I think every municipality or state Department of Transportation is likely already collecting a lot of scenarios of which connected vehicle technologies could help support. What I find very interesting is this conversation where we've split the stack in half, right? And while we're very confident on the lower levels of the stack that'll continue to move forward, and we'll see natural adoption of what's happening today, that journey will continue, right? We expect that journey to continue into next generation wireless, and maybe even getting into microwave and other even millimeter wave technologies as well. And so as we look towards the future, I'm very interested in the upper layers of the stack, because that's where I see a real difference beginning to happen. To your point, let's talk certification for a minute. There's things that can be done in your facility. There's things that can be done there that certifies a base level of functionality between the RSU and the OBU, or two OBUs, if it's a vehicle-to-vehicle application. And then when that base level of functionality comes and I'm ready to test it in my street environment, it may be different. That's the physical attributes of that environment are different. The RF attributes in Austin are definitely different. We have quite a tech-forward community here. As I always say, is once you're done testing the unit in a facility like Tomas's, come to Austin and see how well it works in a crowd where everybody is overpowering their radios and yelling at you at the same time. I think that's a great opportunity to really stress test some of the not just the physical units and their functionality, but how well do the applications operate when in these conditions. And I think that's that last level of testing and certification that's left, considering that we're in a safety critical technology. This isn't like Wi-Fi. This is where we really differ from a lot of commercialized RF networking services, in that if someone misses, a part of a message or a part of a frame that's related to the latest movie that they're streaming across the air, that's one thing. However, in our environment, missing packets or missing information, or having these technologies not work like they're intended to, could have more drastic consequences. And so, Omniair, as you know, has developed an initial set of test cases for certification testing around C-V2X. It's been quite the sprint to see happen over the course of COVID. Those that are part of those committees, as an executive member, I thank you for continued involvement in that in a very uncertain time. But I'd like to ask everyone this one question. This is the only question, and I'll do round robin. But why is it important for the industry, for Omniair, to continue to certify those devices? And I'm going to ask you, it's going to be a two-part question. And what are you seeing as global companies? What are you seeing as the difference between what's happening with Omniair in the United States and what's happening in other countries? And I'll start with Jim.
All right, thank you. Yeah, it's an excellent question. The benefits of this technology come from mass deployment, right? If only a few thousand cars and a few thousand RSUs are out there, you don't get the benefits. You got to go big. And to go big, you need to have multiple vendors involved across the whole ecosystem. And what that means is, as you mentioned, for safety critical communications, you've got to have interoperability. Multi-vendor interoperability is key to making sure that the ecosystem is successfully deployed. And so that means everything from the chipset through all the layers of the software, to the modules, to devices, to OBUs and RSUs. We need to make sure that everything plays together properly to get the full benefit. And so certification through Omniair is an important part of that. We have, there are organizations that write test specs. So in Europe, we have test specs that were developed by 3GPP, and ETSI and GCF can use those test specs, but there's not a certification program. And there's two aspects to certification. One is called conformance assessment. Does the technology meet the specifications? Does it implement the specifications in the proper way? And the other is interoperability. If you know that just because you built the system to meet the specifications doesn't mean that they all work together. And so there's two components to this, and Omniair really does both. And that's a really key, important part of this, getting the technology out there for societal benefit, is making sure the devices meet the specs, that they interoperate, and then those use cases, those wonderful use cases that help save lives, can actually work across multiple vendors, across multiple geographies.
Thank you, Jim. Laszlo, from your perspective as a provider of this technology to OBUs and RSUs across the world, how is this level of certification testing important in your business line, and how do you see this testing progressing over time as well globally?
Yeah, it's really hard to say anything new what Jim just mentioned. So, but just a few one from our perspective. So it's one of the most important factor. I mean, to have certified equipment on your hands, whether it's a full end-to-end solution, including hardware and software, or just the software.
Uh-oh, I think Laszlo,
Can you hear me?
Yeah, you're back.
Sorry, glitching on my end. So basically, this was really important for us as a vendor, and we are really great to see that Omniair has been doing this activity, and similar entities or Omniair should do this globally, not only focusing on the United States, because for us, we face sometimes situations where every vendor implemented the standards the same way, but eventually we were not able to communicate with each other. So maybe there were loopholes in the standards we had to figure out, or simply some kind of implementation bottlenecks at one side or the other. So with the certification, obviously you can fill those gaps and you can skip those unnecessary repetitive steps, whether it's a simple demonstration for a city, or really some kind of performance evaluation with an OEM or a tier one in the automotive. You can simply skip those steps or simplify those, because you have a checklist, you have a stamp that your device or your software stack is basically compliant with these and these requirements and specifications. Obviously, on the higher level functionalities, you have to repeat a couple of things, but not starting from square one and doing these really time and effort consuming methods. Location wise, it's really great that we have this in the US. Unfortunately, we don't have such thing in Europe. Other than the very basic things, the CE marking or radio emission directive. So it's a bit behind, but it's crucial really to have something in common, because until that we will have to do interoperability events, whether it's really a public one like a Plugfest event like this one, or the European ones, the so-called the plug test. But occasionally, if we are working on a project with competitors, which are competitors sometimes because we have to work together with them, right? Speaking the same language. Occasionally, we spend the time the first few days or even weeks to really fine-tune the system to be able to communicate with each other, and we should really skip that step with certifications.
Yeah, that's interesting. We're in the U.S. We find ourselves in some ways, behind our colleagues in other regions of the world as it relates to, universal mandates around technology or other things. But it's great to see that in the area of certifying interoperability, the United States is helping lead this overall charge of really looking at what the end outcome is, regardless of the type of technology that's used today, the type of base bottom layer technology that would be used in the future, that we're beginning to focus a lot of our efforts in that upper level of the stack. I know that, as an infrastructure owner or operator, one of my key concerns is making sure that level of interoperability is there. Otherwise, I do not want to foresee a future where we have to administer through a post-situational awareness after a a fatal crash happens in Austin, that, you know, oops, if that person had just downloaded a different application onto their vehicle, or if that application or connected vehicle application that was implemented from that vehicle manufacturer, you know, that we don't want to run into that eventual future of where we're noticing that interoperability or the lack thereof between certain applications on vehicle or on street, or at some point in time in the future on a handheld, if it's pedestrian safety analytics, that is not done in a way that doesn't have that level of not just conformance testing, but level of interoperability testing, because otherwise, how many people are we really saving? And that's important to me. That's important, I think, to each of us. It's one of the reasons that we're all a member of OmniAir. You know, Tomas, from the perspective of what you're seeing as far as the built environment needs goes, specifically as it relates to this level of upper stack testing, how is DEKRA preparing its test environments for things above the physical and MAC layers?
Yeah, actually, I think we have equipped ourselves with all the different needs in order to address all of the higher layer testing, obviously, including the application testing, which comes then on top. And I would like also to make some additional comments to what was said. And I think when it comes to this kind of certification activities, to be honest, for me, it's I call it always a glue between all the different stakeholders, really to proceed here on the way of developing a successful technology. And that's been always the case, especially in global technologies that have been started somewhere, typically in a little corner in a certain region. For example, in when you look to GSM in the early Europe, where also very early stage there was a certification process in place, stepping up from conformance to interoperability. And to be honest, I think we all can just go back and really see how that has driven this kind of technology forward, where that was then spread all over the world. And I think this is very, very important. I think from this historical perspective, sometimes it's really being forgotten. But if you really look back and you see why, you know, cellular also in that way was developed to be such a successful technology, I think there are reasons for this. And definitely certification in what you just said, also addressing the different aspects, what you said, not just conformance, but also interoperability. This is extremely important. And I think you have to look into this across all the different layers that are being involved, not just the BIRA technologies, especially the higher layers, and now in the verticals. And I think this is now new, I would say, the whole world, because I mean now connectivity meets all kinds of verticals, and automotive is one vertical, yeah, where the application is more or less the one that is really playing the important role, that appeals the business, appeals consumers, and we need to ensure that this is addressed in the appropriate way. And again, this is another step, but the methods are the same, and certification is a key really to make sure that we are here on the right track.
Thank you, Tomas. And it's interesting to me that you know, I think you know, if I look at something that was a more recent addition in ITS space just 20 years ago, that being NTCIP in the United States, where the United States tried to bring forward a communication standard and have people conform to it. It was a very good lesson learned, and that conformance to a standard does not equate to interoperability. And that was in something that, quite honestly, did not involve a level of pervasive application set that we see today in connected vehicle. You had just a few applications, be it, you know, moving a camera or putting a message on a dynamic message sign, or being able to collect and ingest vehicle detection data off the ITS network. So really very limited in what applications would be run. They were more standardized around the country as far as how they were being done. And I see something completely different with connected vehicle, where each locality within just the state of Texas, we're going to have different driving conditions, a different driving culture, if you will, and then a lot of the applications are having to bridge that human to machine interface between how people drive, how people utilize the built environment. Moreover, what are some of those nuances between certain areas around the world that really helps it helps identify and ideate what our safety scenarios and solutions are, which is when I start looking at a company like Spirent, for instance, Alain, and how you're going to help me test out these use cases. So as a last parting shot, one of the things I'd like to know from you is, as we see this convergence happen, and as we see what we've heard from Jim and Laszlo and Tomas, from what we're experiencing from the marketplace begin to evolve and open up, I think that opens up unique demands on how cities will look at certification in the future. It's not as simple as, do you conform to a standard? Can you give me a product sheet that says that you do it? Do you have a stamp of approval on that? But moreover, these use cases and applications may change minutely between locality to locality around the global region, as well as within any country. How is Spirent looking at that level of activity and being able to support the end deployers, in this case myself? And so last question is a little bit more selfish to me, but how over time are you going to continue to help me make sure that I'm deploying the most interoperable solutions out there?
Yes, thank you very much, Jason. Yes, I think all other participants already mentioned some key points there with regard to certification. I think the only one I can add that comes to my mind will be trust. I think the certification program provide a certain level of trust that will allow us to actually have the flexibility that we can provide to our customers. So when we are reusing a module, including a Qualcomm chipset, or leveraging on a protocol stack by Commsignia or by another a stack provider, we can be confident that it meets certain level of quality, it meets the requirements of the standard. So we don't have to worry too much about that anymore. And with that, we can provide test tools that are automated, and that gives the flexibility to adapt to the different regions, to the new changes to the protocol stack, to a new version of the TCI, to automate the testing process, and so on. So that's, we leverage on all that. So we also, as a test tool provider, benefit from the certification. And we hope that it helps us also driving the whole industry forward.
Excellent. And just to close, since we're out of time, and if there were any folks from the participants that have any specific questions, please send them in, and we'll try to get answers back to you in written form. But just in closing, I'd like to take that analogy around the warm blanket. It seems like to me, guys, that we all have one. It's interesting that the OSI stack is that warm blanket, and then it just so happens that warm blanket has a bit of an extra embedded device in it, and that's the fact that you can turn it on and it continues to warm you. In a lot of ways, I see that as being the Omniair certification industry and the certification industry worldwide. Is while having the stack is important, that helps guide us in our work that we do. Having opportunities to bring ourselves together from a multitude of different providers helps ensure that we're finding ways to make sure that this life-saving technology is interoperable for people that want to deploy it, like myself. And so with that, I'd like to thank everyone on the panel today. Thank you for your time and expertise, as well as your insights and perspective on this worldwide need. And then as I want to also mention that next up, we'll please stay tuned because there's going to be a fireside chat between PJ Wilkins, Executive Director of EasyPass Group, and an Omniair Vice Chair, and Maxime Flamand, who's the Chief Technology Officer of the 5G Auto Alliance or Auto Association. And they'll be doing a fireside chat around how what they're seeing as far as market trends for C-V2X around the world. So please stay tuned for that. And thank you everyone again, and y'all have a great day.
Thank you.
Thank you guys. Have a nice day.
Bye.
Yes. Bye-bye.
Bye-bye.